Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the compound. Both structures appear to be 2,3-dibromobutane derivatives or a related vicinal dibromide with 2 stereocenters. Each molecule has 2 adjacent stereocenters bearing Br substituents. Moving on to the next step. Assign configurations at each stereocenter for compound 1. Using the wedge dash notation, at the upper stereocenter, H3C is on a dashed wedge going back, Br is on a bold wedge coming forward, H is implicit, and the chain continues. At the lower stereocenter, H is on a dashed wedge going back, and Br is on a bold wedge coming forward. Careful assignment gives one center as R and the other as S, or both R or both S must be determined carefully. Moving on to the next step. Assign configurations at each stereocenter for compound 2. The right structure shows CH3 and Br on bold wedges at the upper center and Br on the left with H on a dash at the lower center. This suggests the configurations differ from compound 1 at one but not both centers. And for the final step, compare the two structures. When the RS assignments are worked out fully, compound 1 and compound 2 have opposite configurations at one stereocenter but the same at the other, i.e., one is RS and the other is RR or SS, or they are 2R, 3R versus 2R, 3S, etc. They are not mirror images of each other, which would make them enantiomers, and they are not identical. They have the same connectivity but different spatial arrangements that are non-mirror image stereoisomers. Definition check. Diastereomers are stereoisomers that are not mirror images of each other. Since the two compounds have the same molecular formula and connectivity, are stereoisomers, but are not mirror images, their configurations differ at one center but not both, or they differ at both centers but are not full inversions, they are diastereomers. Eliminate other options. Enantiomers would require all stereocenters to be inverted, full mirror images, that is not the case here. Mesocompounds refer to a single molecule with an internal plane of symmetry, not a relationship between two molecules. Identical would mean superimposable, they are not. Therefore, the correct answer is A. Therefore, the correct answer is option A.